Hi everybody, this is a homework problem that many students have difficulty with, so we're going to run through it. So we start out with the city of Annville, which we're going to highlight in green. Annville has a current population of 12,000 people, and the city is growing at a rate of 5% per year. The other city, Brinker, which we'll color Brinker in blue, currently has 9,000 people and is growing at 7% a year. So Brinker is growing a little bit faster than Annville. And the question is, in how many years will the two populations be equal? And there's also a hint saying use base E on this one. So what we're going to do first is we're going to create an equation representing the population of Annville at time t. So you could say that P of t, the population of Annville at time t, is equal to 12,000 people, their current value or the initial value, times e to the 1.05 t. Now we're using e because they told us to up here that it's an exponential growth, but the 1.05 means 5% growth each year. So the 1 means you maintain your current population and the 0.05 represents 5% growth. So this is the population of Annville at time t. We're going to build a similar equation for the town of Brinker. So the population of Brinker, which again we'll do in blue, is their current population, 9,000, times e to the 1.07 times t power. Again, their initial population is 9,000. We're using a base e, and their growth is 7% a year, which is represented by 1.07. And t is, of course, the number of years in the future that we want to know what their population is. When the question says in how many years will the populations be equal, they want to know when will P of t for Annville equal P of t for Brinker. So we're just going to take these two populations and set them equal to each other. And what we have to do now is solve each one of these equations for t, or get t by itself somehow. So that's what we're going to do next. In order to solve these for t, we need to get the t's on one side of the equation. And probably the easiest way to do that is to move the numbers to one side and the e values to the other side. So I'm going to rewrite this as 12,000 divided by 9,000 equals e to the 1.07t divided by e to the 1.05t. So essentially, I took my 9,000 and I divided both sides by 9,000, and then I took my e to the 1.05 and I divided both sides by e to the 1.05t. 12,000 divided by 9,000 reduces down to the fraction 4/3. And now to reduce the right-hand side, you have to make use of the quotient rule for exponents, which says if you have x to the a divided by x to the b, that is equal to x to the a minus b power. So we can rewrite the right-hand side as e to the 1.07t minus 1.05t power. We can simplify this further by writing it as e to the 0.02t power. And now we have an exponential equation with the variable in the exponent. And in order to get that variable in a format that we can evaluate it in, we have to convert this into logs. So the equation becomes log base e of 4/3 equals 0.02t. Now to get t by itself, we're going to divide both sides by 0.02, and we'll get t equals log base e of 4/3 divided by 0.02. And now we're going to do some simplifying on this. The log base e can be rewritten as the natural log, ln, of 4/3. We can also rewrite the 0.02 as 2/100ths, which is 1/50ths. So instead of dividing by 1 over 50, we could multiply by 50 over 1, and that will give us 50 times ln of 4/3, which if we plug it into a calculator we'll get approximately 14.38 years. And that's the amount of time it will take the town of Annville and Brinker to have the same population.